Hey everybody, this is Mr. Beckstrom, and today I want to take a look at section 6.6, and here we're going to try to find all the solutions of this equation here. Tangent of x is equal to -1. So I put a unit circle over here so that way we can kind of visually take a look at it. And I think the best way to do this is to really kind of take a look at what is tangent of x defined as, and as far as sine of x and cosine of x. And if we look at it, tangent of x is equal to the sine of x divided by the cosine of x. And we want the sine of x over the cosine of x, we want that to equal -1. And in order for that to equal -1, we need the values of the sine of x and the cosine of x to be the same, but we just need the signs to be the opposite. So, for example, we need the values to be the same, but the top can be positive and the bottom can be negative, or the top can be negative and the bottom can be positive. So just the signs alternating, but the values to be the same. So if I look over here and I'm just looking at these values here, so for example, pi over 4, they're both the same, but if I look at the sine of x over the cosine of x, or y over x, that gives me a +1, so that's not it. This will give me a -1 because that's square root of 2 over 2 over negative square root of 2 over 2. And here's another one. This is going to be negative square root of 2 over 2 over positive square root of 2 over 2. So that's going to be a -1. And this is going to give me a +1 here because that's going to be negative square root of 2 over negative square root of 2 over 2. So the two angles that's going to work for this on this unit circle is going to be, if we're finding the solutions in radians, will be 3 pi over 4, and it'll be 7 pi over 4. And it'll also be all the coterminal angles of both of those. So we can just kind of go half of a circle, and we can keep going either way. And that's a nice distance to go, because that way we don't have to write it as two separate angles and then go a full circle for each one. We can just write one of these angles and then just go a pi. So for example, we'll start with the first positive angle, the 3 pi over 4. So the solution is going to be 3 pi over 4. That's the first positive angle we have, plus pi times k, where k is, this is an element of integers. Integers can be written like this. It's a z with a little extra line through it. This is just a notation for k is an element of integers. So, for example, if I were to let k equal 0, that would be 3 pi over 4 plus pi times 0, which is just 0. So 3 pi over 4 would be an answer. If I let k equals 1, we would have 3 pi over 4 plus pi, which would pull us over to the 7 pi over 4, and that would be a solution. If I let k equal 2, then we'd have 3 pi over 4 plus 2 pi, which would add a full circle, so it would give us this one over here, which would be, I'm not sure what that would be, but I could pull it up in my calculator and find out. So if I did 3 over 4 plus 2, enter, convert that into a fraction, that would be 11 pi over 4. And I could just keep adding values, or I could, remember, integers can also be negative. So I could do 3 over 4. I could put a negative number in there. So I could do plus a -7, for example, and that's going to give me a solution to this as well. So let's try that. Convert that to a fraction. So negative 25 pi over 4 would also be a solution. So if I were to go back to radians here, and if I were to say, what's the tangent of negative 25 pi over 4, negative 25 second pi over 4, it would tell me, hey, it's negative 1. So all of these are solutions. So any integer I put in there for k will give me a solution. So this is an infinite set of solutions right there. All right. If y'all have any questions, let me know. So just a real quick kind of extra tidbit here. In the case where the angle repeats every half a circle or every pi or every 180, we can just write it as one solution set where it repeats every pi times k. But if it doesn't repeat every half a circle, like let's say, for example, it's a sine or a cosine one, and it's 3 pi over 4 and pi over 4. So we have these two angles. So it's this direction and this direction. Then you have to actually write it as two solutions, and each one of these will repeat every 2 pi k. So, or 2k pi, however you want to write that. So the only time I can write it as a single set of solutions is when it repeats every half of a circle. All right. I hope you all have a great week, and we will see you next Monday and get ready for the test. I went ahead and put out the test review. All right. Thanks. Bye-bye.